Okay, and as I said, recording, there is a little bit of a his background, but hopefully that will go away once we get started. And anyway, I'd like to just welcome you all. This is our webinar that hosted by the Northwest Fire Science Consortium, and your speakers today will be Chris Zanger-Stern and Algo, all from the Nature Conservancy. And we're going to kick this off, and I'll let him and introduce the topic and give you background into the project. Questions, as they come, use the chat, answer questions, and we will be those as we move forward, and we should be able to get to every. So without further ado, I take it away, Mark.
Okay, thanks Janine, and thanks everybody for tuning in this afternoon. As Janine said, with the Nature Conservancy here, and along with colleagues Ryan Haugo from Washington and Chris Zanger from Oregon, we're going to give a presentation about that's been partnership work that's been ongoing with the Forest Service the last couple of years. I'm going to speak briefly here of the context, sort of why and how this came together, and then pitch it to Ryan and Chris, who present the material. I think, as most of you probably know, Conservancy in both Oregon and Washington, conservation priorities is committed to trying to see resilience across the fire-adapted landscapes that span the southwest Oregon, eastern and eastern Washington as well. And it's something that both chapters have been involved for several years. Continue to work on with all of you and our collaboratives, Forest Service and the BLM at large. So certainly a joint effort that's interest. And about 2 years our Learning Network conference in Bend as part of the conference about how do you use and scale restoration in these dry forests. Ryan and Tom DeMeo from the Forest Service all began talking about, well, how do we estimate the magnitude of the need in our areas? And Chris had been working on it in Oregon, Ryan had been working on it in Washington, and Tom had been working on it with his Forest Service peers. And from that conversation really came the idea, well, why don't we all try and work on it together for a couple reasons. One, we'd benefit from our shared knowledge across the landscapes and resources that we could apply to it. And also, and maybe even more importantly, that it would allow the Nature Conservancy, the Forest Service, and others to have one set of data to talk about and talk from as we tell the story about the restoration need in these fire-adapted forests, so that we'd all have sort of the same point of reference and baseline as we made our way forward. And so what we thought was going to be a 6 to 8 month project turned into more like an 18 to 20 month endeavor, which culminated earlier this fall when the work that Chris, Ryan, Tom DeMeo, and other colleagues there from the Forest Service Ecology Program came forth with a peer-reviewed manuscript that was released in September. And I think, again, the value of the manuscript is it really looks at Oregon and Washington adapted forests and describe the magnitude of the restoration in these systems. I think helps frame the context of when we talk about increase in scale, how much work there is to do and what it's going to take to get a resilient landscape in these fire-prone systems. And so with that, I'm going to pitch it to Ryan here and let Ryan and Chris kick it off, and we'll go from there. So Ryan, it's all yours.
Great. Thanks, Mark. Thanks so much for that introduction. And again, I do want to acknowledge upfront the number of very close and excellent collaborators that we've had on this project, including folks from the Nature Conservancy, myself and Chris Sanger, and Mark, and Corey Blankenship with the LANDFIRE program, Tom DeMeo with U.S. Forest Service Pacific Northwest Region Ecology Program, Chris Ringo, Ann Schlisky, Mike Simpson, Kim Mellon McLean, Jane Curtis, and not just the co-authors, but we've had a number of other individuals been with us process and have provided just invaluable feedback and advice. So we certainly would not have gotten this study without everybody. In here, I'm sure as pretty much everyone on the phone is well aware, historically fire was a very important part of many of our forests in Western North America. And that there's unfortunately a very common storyline for these historically fire-dependent forests. Anyone who's watched the evening news or read a newspaper during recent summers knows that in our forests we're experiencing a dramatic increase in the extent of both fire and defoliating insects. Many, but not all of these events are outside of the historic range of what these forests are adapted to, either the and or the severity of these disturbances. And characteristic impact not only the tremendous biological diversity that's supported by these forests, but also the benefits, the clean air, water, fiber production, recreation, that millions of people depend upon. These events, along with others, have helped drive a fairly dramatic shift in the management of our public forests across the West. We're living in an age in which ecological restoration is really becoming a new management paradigm for many of our forests. But with this shift towards a focus on restoration, we, land managers, stakeholders, collaboratives, policymakers, we still struggle with answering, with defining where, how much, and what kinds of forest management are needed to achieve restoration at the scale of large regional landscapes. And it is this question of where, how much, and what kinds of forest management are needed to achieve ecological restoration at regional scales that is at the heart of this study. And answering this question, I think, is really important because, without having this regional scale understanding of restoration needs, it's difficult for us to ask, are we making a difference through our restoration efforts? Is the pace and scale of our work being the need? And that this study is the first step to answer that question. So now we're going to dive into the guts, the details of what we've done with the study, and for that I'm going to turn it over to Chris.
Excellent. Thanks, Ryan. Can everybody hear me okay? Hopefully one person can say yes.
Sound good, Chris.
Thank you, Ryan. And so we're project was kind of opportunity for the kind of TNC, Oregon, Washington, and the Forest Service to work together, but also to kind of work towards a common set of objectives with this explicit number acres that we're needing kind of to look at of the restoration need, and not just in the past how we've kind of framed this conversation on there's this much departed or that much departed, but what is the restoration need associated with that departure? That, where, how much, and what kind. And also we were able to kind of address the disturbance and successional restoration need in the past, addressed primarily the disturbance need. We were able to bundle that in here as well. The side, again, as we mentioned earlier, the in Oregon and Washington, and we also make this a broader scale and look across all ownership. And we also, this best available data, we've had the kind of team that worked on how we wanted to go about it, and settled in on this process of what's the best, and we'll build from that, and I'll get into the specifics here in a sec. Built on great work that we've kind of co-opted from both the LANDFIRE team, region with Tom DeMeo's team, and then the way Ryan's addressed it in Washington. And kind of all of us has looked at this, and we kind of took us into this one common project. What this whole process off with is what's the appropriate. So I want to frame that in that is that we're looking at the Provincial kind of large landscape that we're summarizing the restoration for. And I know a lot of people out there are working in some project planning and have some interest in this, and down to a specific unit or a stand scale, and all of those are super valid and have their own inputs and data sets associated with those. But the results from this really are most appropriate at the provincial scale, and then some summary numbers that can up in the water scale. But it's really important to kind of think of this as the 30,000 foot look of and the results are talking about. Just to kind of give you a quick primer on the inputs and some of the analytical products that we use going. Start with the mapping and classification of systems. So what is potential veg type? What is the geography, so to speak, that we use the ILAP outputs, which also covered all of Region 6, so it worked out great for that. The reference conditions, so we determine the successional stations, and these are coming our LANDFIRE B settings, and I'm sure you're familiar with those products as well. And then how do we delineate the land kind of meaning units of analysis? And we're looking at using specifically hives for our frequent fire or frequent disturbance systems, HUC for our and then regions, and you'll see some of these in the map later on for our longer term return disturbances. So current conditions was based on GNN, which again covers all lands, all ownerships in the whole region, and this project before the some newer data was used, the 2000, and we're in the process of summarizing the 2012 to be available. So advancing slide, there it went. So again, our methods worked across all lands, and our main focus is our only focus is on the forested lands in the eastern portion of the state and southwest Oregon, primarily where the home of our frequent fire forests, and so we wanted to kind of pick a geography that captured the historically fire-dependent systems. So to kind of walk the methodology and how this process worked, we're going to use an example here, and I'm going to work the group through this. So in this example here in northeastern Washington, we look at these potential veg types, as you can see here. They're in these map zones or map regions. East Cascades, Blue Mountains, Northeast Oregon. And so we broke this down into what we're calling strata. And this strata is going to be this potential veg type in the unit that the system operates at. And so the example we're going to use here is going to be this mixed conifer dry, which is this light blue on the eastern flanks of the Cascades here. And we'll kind of walk it through the whole process of how the strata gets classified and worked with its reference condition or range of variability. So here is kind of the reference condition for this dry mixed conifer and its reference range of variability. So these are the 5 successional classes that we looked at with the reference condition model across the bottom, and then their relative abundance per strata. And so in this case, the strata is going to be the Huck 5, and this is how much of that dry mixed conifer exists in that Huck 5 as a percentage. So we get these reference condition means, and these are the modeled outputs from the LANDFIRE BPS and all the great work that the LANDFIRE team has done. And then we kind of expanded upon that in a little bit, and we picked a range. So in the past, we've always looked at this mean number of that's the reference condition. Now we wanted to look at bring in the concept of the range of variability, and so we have a little bit larger spread there. And so you can see with the polka dots across the middle, the dashed lines, that's your mean, and then the spread is your reference condition. Successional class doesn't necessarily represent this healthy or unhealthy condition. It's more just the appropriate amount that was in each of these states in a historically resilient condition. And so based on that original reference condition, we applied current conditions over the top and looked at the differences. And so here with the blue, you're seeing your current condition. And so this is what is currently on the landscape. And we wanted to kind of talk about the difference and the restoration needs based on that current. And so here is where we start to look at the difference between the reference condition and the current condition. And again, this is for each individual strata or the system that it operates at. And so we're looking here at each forest type within the landscape and which successional classes have like an excess of acres compared to the range of variability, which would be that red arrow, and then which successional classes have like a deficit or a need, which is going to be that orange arrow. And so the basic idea of the study is asking what needs to happen in order to move those with an excess into those areas with a deficit, or from the red to the orange conditions. And so we kind of put that process together, excuse me one second, I try to advance this slide, through these set of rules. And so if we were to look at, for example, like this mid-close that had a overabundant excess of conditions and we needed to move it, we would take that mid-close here and talk about how it could get moved across the landscape based on some actions. And so these are kind of all of the possibilities or this rule set that we developed for each of the systems. And so we had one for the dry mix con that we're using in this example, but we had them for all of the systems in these rule sets, and they were different depending on what was most appropriate ecologically. And here you can see that there is a whole kind of specific group of type of actions, and then they've been lumped into kind of these larger categories of disturbance only, successions only, and then disturbance and then succession. And here is kind of a clearer slide of the categories. So the disturbance only transitions are those ones that go from your mid-serial close to your mid-serial open, or your late serial close, your late serial open, through the active management or a disturbance. And then the successions are the ones that require time to grow. And then the disturbance, then successions are ones that we would take from like our mid-serial closed to our mid-serial open, and then further onto our late serial open through starting with an active management and then using a growth or time to kind of make that transition. So these three are the broad categories that we summarized our results through and have kind of framed the analysis of the project with. One thing that I wanted to mention is we get into this concept of, if we were to this is what the need is. Well, in all of these cases, that's a static snapshot, and so we're going to have some level of maintenance that is needed. And so just because it was opened, it doesn't mean it's done. It's going to need some level of maintenance over time, and that includes prescribed fire and others to kind of keep it in that open state once it gets opened up, because as we all know, it can return pretty quickly to that closed state. So there's kind of the summary of the overview of our process, and then Ryan is going to take it through and discuss how the results and what that all means.
That's the map ranging from the blue to red, or in need of growth and older class on the right. That's the green to purple. So then what's driving these patterns that we see across our region? And the first factor, which was key to these patterns, is the distribution of our different forest types within a landscape and within watersheds. So this is a figure, again, pulled from a journal article that displays the restoration need within each region by the different historic fire regime groups for each type of forest. So in this figure, FRG1 that stands for Fire Regime Group 1. Those are forests that were historically characterized by a frequent low-severity fire regime. FRG 3, those are forests that were historically characterized by a mixed severity regime. And FRG 4 and 5, those are forests that were historically characterized by more of a high severity fire regime. And what we see across nearly all of our regions, not surprisingly, is that restoration needs and the disturbance needs, more specifically, were concentrated in the forest types that were historically characterized by low or mixed severity fire regimes. And so what this means is that when we look at a region which is near the Cascades, where we see that at the watershed scale, there are relatively lower disturbance needs. But when we zoom into this, you can see that those watershed levels are driven by the really steep ecological gradients that we have in the East Cascades, where there's a rapid transition from low, dry, historically frequent fire forests to wetter middle and upper elevation forests, within a single watershed. So when we zoom in here, we see that while the watershed level disturbance needs might be lower, locally there are still very high needs for disturbance to be reintroduced, primarily concentrated in those dry forest types. Within the mixed conifer dry potential vegetation type, that's PVT, within the East Cascades, nearly 47% of acres within that forest type are in need of disturbance today. So the second factor that had a large influence on the regional patterns of restoration need were patterns of forest ownership. And so when we look at, again, the regional map of disturbance restoration needs, two of the regions that really pop out with having high watershed level of needs, Southwest Oregon and Northeast Washington. These are regions where there are also relatively larger, levels of forests that are owned and managed for industrial purposes. And it's easy to imagine that with greater levels of industrial forest, you have a lot more forested acres that are kept within a younger, closed canopy condition. And so we see that similarly in the successional needs as well. Northeast Washington, Southwest Oregon are two that pop out again. And you can think about how the conditions that industrial forests, would primarily be kept within are influencing these watershed and regional level restoration needs. And that's evident too when we similarly summarize the restoration needs within each region by the primary ownership categories. We see within Southwest and Northeast that there is a high level of restoration on private land in Southwest Oregon, private lands within Northeast Washington. And this contrasts quite a bit with some of our other regions, such as the Oregon Blue Mountains and the Oregon East Cascades, where Forest Service lands make up a much larger percentage of overall ownership and a larger percentage of the overall restoration needs. And so I see Mike has put a question on detailed results available for watershed level and landowners to use. And one of the pieces of this study is that in the appendices, we provide some fairly fine detail of both the data that went into our analyses in Appendix A, but then in Appendix B, we break down these summaries of current conditions and reference conditions for each of our strata. We break down these restoration needs in detail by each ownership category within each region. We break down the restoration needs by each forest type, and we break down the restoration needs by each fifth field watershed. And so these appendices are available with the journal article. They're available on two different websites that we've got set up. I'll show you that in just a slide here. But part of our hope of this study was both to present these large regional needs, but to also provide information that land managers and collaborators could use to help place, the watersheds, the projects, the landscapes that they are working in into a larger regional context. I think it's really important to keep in mind as we look at these results and talk about the implications of this work that what we're presenting here are not silvicultural prescriptions in any sense of the word, and that in developing putting restoration projects on the ground, local landscape evaluations incorporate spatial patterns and aquatics and wildlife and species. Those are all incredibly important factors that do certainly need to be incorporated into our restoration work. What we've used here is a somewhat simplified format that has allowed us to make an apples-to-apples comparison at regional scales across multiple ownerships. But even at this regional scale, again, we understand that this is only one input that may be used for regional scale prioritization, and that as our mapping of forest types and our understanding of reference conditions, as those are updated, that will naturally change the results that we have presented in this study. And so with that, be very happy to open up for questions and discussions. At the bottom of the screen here are the two websites. One is at Conservation Gateway. The other one is EcoShare, a Forest Service, both of which contain links to the journal article themselves. The EcoShare site has all of the appendices, all the GIS and the reference model data. So everything in the study is available for everybody at these websites. And so with that, let's jump into discussion.
Thanks, Ryan. That was great. This is Chris, and I unmuted my mic so I can kind of join in on this discussion as well. Mike, I see your question, and I'm hoping that you feel we've answered that with kind of the availability of the appendices and also where the data is available on those two sites.
And then it looks like the question is, how confident results in Oregon, given the challenge of not being able to determine species type easily, structure, may restoration. Chris, do you have any thoughts while I put my thoughts together on that?
Yeah. So Southern Oregon is a really diverse and complicated landscape, and we went round and round on some of the results down there. The thing that I think we got right we used the updated and kind of collaboratively developed PVT map that literally came out in mid-process, and so we kind of stopped and reused that. So I felt like we were capturing the system as best could be for that whole geography based on the new updated mapping that system. But then the diversity of this within that system is definitely something that can add to some variability. And then also some species compositional changes where, we're looking at the system and the structure of the trees in there, but we may have had through management or fire suppression or others had changed positions. And so we may be looking at structures that are actually not the historical system may have been. And this is, again, in some cases, it's definitely not everywhere. So I would say moderate to high evidence in Southern Oregon. And again, that's looking at the landscape level. If you were down at individual or even at the unit level, I think you're going to have a whole nother level yous related to what's going on down there, and then how you as part of the thank yous, ecologists from the agency and the forest and the BLM as the reviewers and a part of this process, and their reviews felt that we had as possible.
And so another question coming up here: what did we do with the serpentine lands in southwestern Oregon? And I think, as described, we resources that we had mapped out the forest types on serpentine lands and its conditions that reflected that ecological reality. And I think
so.
Chris, did you want to jump in there? Did I hear you?
Just one thing to make a point to answer that serpentine is I believe we classified the serpentine to the ultramafic. So it was modeled using that model.
Mm-hmm. Okay. So next question, is this approach applicable in areas that do not have GNN data? And where GNN data is available, is there a crosswalk between LANDFIRE BPS and GNN? So I would say that our general framework is applicable in places without GNN data. I've been working extensively in northern Idaho in the Clearwater Basin using the same general framework with forest type mapping and current condition data sets that are available from Region 1, but it's applied the same basic restoration needs framework. And then in terms of a crosswalk between BPS and GNN, one of the pieces of this work was coming out an approach to classify those successional classes by BPS from the GNN data.
But did that we extensive process create essentially crosswalk the GNN data to work with the LANDFIRE models. So if you do GNN data, is very, it could very used with the LANDFIRE-based databases.
Oh, I'm sorry. I just want to make sure that you didn't miss the question that was from David.
Yeah, I saw that Dave about climate change. This is really a shot with the reference condition and current condition. And so when we look at the future, we talk about 1 year and 50 years and downstream all as kind of just the future or succession. And so we didn't get into any climate scenario modeling or pretty much anything that talked about future other than it. And so static snapshot. The climate change models that we've looked at are model at a scale, of like much coarser. So we look at a pretty coarse scale, and so that's another. So it's dealing with the scale of the data and the resolution, and that adds a level of complexity we were just not ready to take on in this project. No, I was going to answer Kevin's question, and you got it, so go for it. Kevin, one of the things that we kind of addressed and struggled with as a team is the scale that the system operates at. And, you know, so if, for example, that mixed conifer is the one of the 1700 that we looked at in the kind of example methodology, you know, that operates at, we as a more frequent fire system at the Huck 5 scale. So really, we cannot summarize results for a finer scale than what we kind of use as the finest scale for the level of the system, and that's why we reported results there. But you ask about departure, and I just want to make sure that we're clear that the departure analysis was what, and then we fulfilled that with the restoration need, but departure and restoration need definitely are two separate things, and how you address the departure is what the restoration need was really looking to kind of capture. Yeah, it is definitely something that we have between Ryan and myself and can make available, but we want to do it with the kind of the caveats and have a discussion as we hand it over. But all of the other data is actually in Excel workbooks, and so those are ready to download that tabular data in a format that we formatted both in I think it's, you know, in acres, so it's a usable units, and they're in Excel workbooks that are kind of ready to go for people in that way. I think it looks like Doug is typing in a question. And if anybody else, we have another 15 minutes. If anybody else has got some questions, please bring those up. And just, okay, great. Just to quickly, I'll go back at this, just to quickly address Trent's question. I just looked at the data that we have uploaded on there, and there is GIS data with that spatial component. So that data is available on there, but I would caution you about using it rawly and tie in with us, but it is uploaded and available on EcoShare. I can do that. There we go. Yep. Oh, there you go. Perfect. So just to, Doug, to kind of make it clear, if you look and not now down the road, we live the possible transitions and then what the kind of what their order of operation and how they were chosen. So if you have a specific potential veg type that you have interest in, you can go and look in there and kind of see the rules that we chose for that specific veg type. Yep, last slide. That's good question. Negative.
I think in terms of providing core district, that is something that would be appropriate and could be done, just with keeping the same caveats in mind.
So that's something that we've been talking with Tom DeMeo and some of the analysts that he works with, and it sounds to me like that's definitely a need out there. So we should talk with them about potentially getting a table together to try to summarize that at the district level.
Mm-hmm.
Hey, Janine, I'm not too familiar with how this works, and I'm guessing that you have everybody's email. If we were to make it easy on folks and potentially just have the links available to them, is that something that you'd be able to email out?
Yes,
Yeah.
we don't have emails
Okay.
of the participants. We don't ask for those, but we can tweet and on Facebook and send
Yeah,
out
I
on
think
the
the
serve.
Conservation Gateway is a pretty
the
cryptic
link,
one because we had to shorten it from a 75,000 character
they
long.
get a pretty
The ecoshare.info, they'd be able to
distribution that
navigate there.
If you would, the links that you would like, are these the web?
Excellent, thank you.
The Gateway to EcoShare.
So Don and Mel just asked at the 800,000 acres on the Rogue River Siskiyou as a fraction of the
Okay.
total forest area. What about the rest of the area? And so I think we're looking at
Yeah,
this.
we actually were planning on adding that into the
Ryan, you
Northwest
put this
Fire
together. I'm
Conservation
I'm
website.
curious if this
We're putting a
includes
link there, so we'll
all.
make sure that we get that out. Mhm.
So this just includes
And so what
the
that would look
sum
like,
of
real
the
quick,
three
is,
different
sorry to
restoration
click
need
back and take over
categories.
the
It
slide
doesn't
there, is
include the total
there's a
acreage.
number of
So this was
acres
an
in
assessment
there
of the total
that for
acreage of Rogue
mid-open
River.
that already fall within the range of variability, not showing
So amongst,
a restoration there.
I don't know off the top of my head
Some
how
of
many
them that
acres
may
are
already
across
in
Rogue
their
River
appropriate reference condition and
Rogue
range of
Siskiyou.
fall out.
It was roughly 800,000 acres that fell into one of our restoration need categories. Mike's question, is there a list of BPS codes listed on the spreadsheet? Yes, there is.
I think we have, I think Don and Mel are typing in some more question.
Yeah.
This is Mark. Just to clarify, I think the question that Don and Mel,
showing
some
that
quick math right, 0.8 million acres on the Rogue Siskiyou. So I'd interpret that as being roughly 40 to 44% of the landscape is in some need of restoration. So about it.
It's that area right in there. How to make this? Here we go.
And then they asked about, so the area of the Biscuit Fire, 500,000 acres. Correct, and so the Biscuit Fire was represented in our current condition data set. And if you, when you look at even at the watershed level map, you can see actually the roughly that outline or that area of the Biscuit Fire within our restoration needs map.
And based and building on that is, I know a lot of people are with the agencies, and Ryan and I are both happy to support and field this, but as Ryan had mentioned, Tom DeMeo was a critical partner on this, and it wasn't just Tom leading the regional ecology program, but we had a lot of support from the different ecologists, either the area ecologists or the
and so as the questions are slowing down here, I just want to emphasize that all of our contact information is on both of those websites. It's on the manuscript, so please don't hesitate to shoot us an email or give us a call if you have any other questions or discussion about these results, how to use the data. We want to do everything we can to make sure that this study is useful to everybody.
there anything coming up? I thought I saw some more typing going on. So let me ask you while we're kind of waiting to see if we're wrapping.
Janine, I think you cut out there. You're asking if there was a copy.
I'm not hearing Janine either.
Well, it looks. Oh, Janine was disconnected, Pam says.
Oh, oh, bummer. So, anyways, a copy of everything is available on that EcoShare site. So the appendices, the GIS data, the manuscript, and all that. So if that, and the contact info. So if you're not getting what you need, please use the contact info, and you can tie in with Tom, Ryan, or myself.
So with that, I see that
We'll
Doug
be
is typing
helping with
in,
some
but
video
we'll
as
see what
well.
that question is, and I think we're ready to wrap it up for today. Thanks so much to everybody for joining us for the webinar and hearing about our work. Oh, looks like the PowerPoint isn't on yet. We'll get that worked out.
Oh. Yeah, that PowerPoint that was on there is actually a link to the PowerPoint that was presented to the internal Forest Service group, and is a little bit different from this one. So this one will be available after this presentation, and we'll have a link from there over to the Northwest Fire Science Consortium. I know that this was recorded, and so there'll be a link to that video. And I believe on the EcoShare site there is a link to the presentation that Ryan and I did internally, and so I hate to drive you through that, but you have the option of watching that video as well.
Well, Mark, unless you have anything
Thanks
else
for the
to
catch,
add, I'd
Doug.
just like to say
Sorry about
thanks
that.
to everybody for joining us this afternoon, and hope everyone has a good rest of their day.
Thank you. It was a good group.
The same thing. So on behalf of Jay, thanks everybody for listening in, and we'll sign off. And goodbye, all.
Take care. I don't think we can end this. There it goes. Mike took over. Perfect.